So now in this video, we're going to look at the op-amp unity gain buffer or voltage follower right there. So that's the main thing. The voltage we set at the non-inverting input is going to be the same at the output, of course, within limitations of the output and the voltage that we're working with. So a trim pot, you put a voltage across it. It's a resistor, and it could also be used as a variable resistor. Then you would not have one end connected to a supply voltage, just the other one, or to something else. But in any case, we have the full voltage across the two ends of the resistive element, and then there's a wiper. So when you do that, some of the resistance to the positive supply, some of the resistance to the negative supply gives you a fraction of the voltage. But if you have to power a load or something, that's going to throw that voltage off wildly. So that's what the rest of the circuitry does. Takes that voltage and outputs that same voltage. So we have the output, and the way that the op-amp knows what the output voltage is, in this case, is negative feedback right there, a direct negative feedback path. The output is connected directly to the inverting input. That's because the voltage wants to be more like the non-inverting input voltage than the inverting input voltage. Therefore, if the voltage is higher here than there, the voltage is going to go up. If the voltage here is lower than the voltage there, voltage is going to go down. But ultimately, it's going to stop in the exact same spot that voltage is. That's what that negative feedback does. Negative feedback brings on stability. So positive feedback makes things more unstable. Just be aware of that. So that's what we got. Voltage we set here will be the voltage out, as long as we don't exceed whatever limits the output has. So it has a certain amount of current that it can provide. And also the LM358 does not get all the way to the positive supply voltage. So we're going to have to stay about a couple volts down to maintain that voltage. If this is a 12 volt supply, we put the trim pot to 12 volts, it'll probably be 10 volts out here because of the limit. But as long as we work within 10 to 0 volts, we should be fine. So yeah, this is the physical component. I didn't feel like building the circuit on the board. I don't think it is, a demonstration circuit is terribly helpful with this. It's pretty straightforward. You got that voltage there being the voltage coming out, but this is a really weak voltage signal. So if you power load, it's going to throw that voltage off. Whereas this can provide power at that same voltage. Within limits, it's going to maintain that voltage even while it's powering a load.